Hi everybody. Today we are going to finish up the 0.3 notes on exponents and radicals, and we're going to do that by finishing up the last part of it, which is on domain and finding the domain. We're also going to talk about the range a little bit. We're going to focus on how to find the domain and range algebraically, but then we will work on finding it graphically, so when looking at a graph. So first of all, I know domain and range is probably not everybody's favorite thing, but there are a couple of questions you can think about to help you figure out the domain of an expression, okay? First of all, your definition is the set of all values for which an expression is defined is its domain, okay? So if we kind of turn the definition into a question, we can always ask ourselves, what can you put in the function? Okay. If you think about a simple expression or equation like y equals 2x plus 5, that question, what can you put in the function? That's overwhelming to answer because you can put everything in the function. If you're sitting there thinking about trying different values, it seems intimidating to try and evaluate each one of those values. So sometimes what helps is to think about the opposite. So what can't happen? Okay, what can't happen in the function? All right, for this problem here, your domain and range would be all real numbers because it is a line. Okay, but let's look at somewhere that's not necessarily the case. I'm going to go ahead and tell this. When we look at the graphs and talk about domain and range, I'm just going to go ahead and throw these words out here so you're familiar with them. We talk about the difference between a continuous domain and a discrete domain. So continuous is going to be if our domain comes out to be from -2 to infinity. It's continuous because it includes all of the numbers between -2 up to positive infinity, okay? A discrete domain is going to be when we have specific values that fall into the domain. For example, if we just had the values of 1, 2, and -7, that worked, okay? That will make more sense when we look at the graphs. For what we do today algebraically here, we are going to have mainly continuous domains for our answers. Okay, so the first thing we're going to do is look at number 7. Here you have the square root of 3x plus 4. So again, we're going to take the approach about asking ourselves what can't happen, okay? So the first thing you should notice is that you have a square root. So we know that we can't have a negative number underneath the square root. So this can't be negative, okay? So to figure out where it's negative and where it's positive, we're going to use the same idea that we've been using for our polynomial inequalities, where we had the test intervals. So the first thing we're going to do is set the expression underneath the square root equal to 0, okay? And we do this and solve for x so that we know where that 0 value is going to be, where the point on the x-axis is going to occur. Okay, so x is going to equal -4/3. This helps us create our test interval. We are going to want to test a number that is less than -4/3 and a number that is greater than -4/3. Okay, so an easy example here, let's do like -5. Okay, if I substitute -5 in up here, that would give us negative 15 plus 4. Again, the number doesn't really matter. It's going to give us a negative number under the square root. Okay, if we test x equals 1 or 0, let's make it 0, that's easier. If I substitute 0 in, 3 times 0 plus 4, it's going to give us a positive answer. Okay, because we know that the expression under the square root can't be negative, we want the interval where our numbers are going to be positive. So this is our interval that we want here. So our domain, let's see, now you have to think about this. As far as brackets, we know it's going to go negative 4/3 to infinity. But do I need a parenthesis or a bracket here? That comes down to, can I substitute negative 4/3 into this expression? I can. I can take the square root of a 0 and get 0, so I'm going to include negative 4/3 in my answer. Okay? Now, if we want to find the range on this one is pretty easy. The smallest number that you can put into a function, the result of that, the answer, is going to be the smallest number in your range. So if I substitute negative 4/3 in here, I'm going to get 0. That means the smallest number in my range is 0. If we can go to infinity here, then our range is also going to go to infinity. Okay. All right, looking at number 8. Now we still have a radical here, but now we have a cubed root. So with a cubed root, there are no restrictions as to the numbers that can be underneath a cubed root. We can have a positive or a negative number. So because there are no restrictions, I can put in positive numbers, I can put in negative numbers, I can put 0 in, we're going to be able to get an answer. So the domain here is going to be from negative infinity to positive infinity, just like it would be with our linear equations. Okay? And again, because the domain is from negative infinity to positive infinity, the range will also be from negative infinity to positive infinity. Okay? If you're not sure you remember about the negative part there, just type in your calculator the cubed root of negative 64, cubed root of positive 64, okay? You're going to see that you will get answers on that. The cubed root of negative 64 will give you a negative 4, and the cubed root of positive 64 is going to give you a positive 4. Okay, so we can have negatives. That's going to occur whenever you have an odd number on your root. Okay, anytime it's an even number over here, that's when we can't have a negative underneath the root. Okay. All right, 2 more here. Number 9. So the big thing you have to watch out here is the fact that you have a fraction, you have a rational expression. So whenever we have a rational expression, we have to be careful of the denominator. A fraction cannot have 0 in the denominator. So this part here can't be 0. Okay? If I set the denominator equal to 0 and solve for x, negative x will equal negative 9, so x will equal positive 9. This again kind of sets up our test interval. You can test a number that is less than 9. So let's say we put in 7. If I do that, that's going to be okay. If I do, well, I'm going to put okay there. It would come out to be a positive, but we could have a positive or a negative underneath the fraction bar on this. And if we try 11, That's going to give us a negative 1/2, but again, that's okay because we can have a positive or a negative fraction. So on this one, the only problem is if x were to equal 9. So there's a couple ways you can write this. I'm going to show you both. Okay. The easiest is just x cannot equal 9. In our interval notation, we would write that as negative infinity to 9 and use the parentheses to show that it can't actually equal 9. Okay. So if that is your domain and we want to find the range, the only number that you're going to exclude by excluding 9 from the domain is excluding 0 from the range. So y cannot equal 0. If you want to graph that in your calculator, you would see that there is an asymptote. So that's why y cannot equal 0. Okay. All right, number 10. Another one we see sometimes is with our more complicated expressions. The easiest thing to do here is to take it one piece at a time. So we're going to look at the numerator and figure out what its domain is. Look at the denominator, figure out its domain, and then figure out what domain will work overall for both parts. Okay? So let's see. I'm going to start with the numerator. So I'm going to rewrite this here. We're going to have the square root of x minus 2. This is what I'm thinking about here. Just like number 7, I know that this can't be negative. So I'm going to set it equal to 0 and create my test intervals and see what's going on here. If I do, let's say x equals 0, if I substitute 0 in here, that's going to give me a negative underneath that square root. So we're not going to use that. If I substitute 3 in, 3 minus 2, square root of 1, that's going to give me a positive number. Okay. So just for the numerator by itself, your domain would be from 2 to infinity. Okay. But we have to make sure that when we say the domain overall for this rational expression, we're also taking into consideration the denominator. Okay. So if we look at the denominator, it's x plus 2, and we know that because it's in the denominator, it cannot equal 0. So it can't equal 0. So if I think about setting it equal to 0, that means we would have x equals negative 2. So we cannot include negative 2 in our domain. Okay? Well, for this one, remember we said for the numerator, your domain would start at positive 2 and go towards infinity. Because negative 2 is already excluded here, we don't have to do a whole lot of adjusting really to the domain. Our domain is going to be from 2 to infinity. Now, if we think about this, 2, can I include it? Do I bracket it? Do I put a parentheses around it? You're going to use a bracket. I can substitute 2 into the numerator. It's okay if I have 0 divided by 4. That just gives me 0. So we are okay to include that 2 in the domain. Okay. And again, for our range here, if I were to substitute 2 into this function, we would have 0 for an answer. And because it goes to infinity in the domain, we are going to go to infinity in the range. Okay. I know domain and range are maybe not the easiest, but hopefully that helps if you can think about what can't happen as opposed to what can we put in it, because that's a little overwhelming. We are going to talk about how to find the domain and range graphically, so that will be coming up shortly in class.